My God, I don't remember where I have to share to make you co-animator. Plus, dividing groups, no. Ah, yes, it was here. Um, just have to find you. There is so many people. That's good, but
Yeah, I DM the post.
yeah. I just have to find you first. And I think after I can give you the role of co-animator. Just l'anglais est cyrillique, hein? Cyrillique, hein? Ah, you are here. Yes. Romeo. Okay. Yes, normally you are co-leader of the seminar now. Okay.
Okay.
Okay, so now I just have to let you to be able to share my screen. Okay, now I have done it. When you want, you can share your screen and start your presentation. Okay?
Okay. So I have just shared my screen.
We can see it.
Okay. And now I can start the presentation. Live,
Great,
right?
great. Thank you.
Thank you too. So hello to everyone. My name is Diana Kinaneva, and I'm happy to be your presenter today. I've been teaching subjects in the field of telecommunication networks for more than 5 years, and today I'm going to talk about the state of the modern networks and also the characteristic of the IPv4 and IPv6 networks. Let's first see how networks affects our lives. Advancement in networking technology are perhaps the most significant changes in the world today. They are helping to create a world in which national borders, geographic distances, and also physical limitation become less relevant, presenting ever diminishing obstacles. The internet has changed the manner in which our social, commercial, political and personal interaction occur. The immediate nature of communication over the internet encourages the creation of global communities. And the global communities allow for a social interaction that is independent of location or time zone. On the other hand, the creation of online communication for the exchange of ideas and information has the potential to increase productivity opportunities across the globe. And the creation of cloud lets us store documents, pictures, and access them anywhere, anytime. So where we are on a train, in a park, or standing on top of a mountain, we can seamlessly access our data and application on any device, everywhere. Networks have become an integral part of our lives. They change the way people work, communicate, collaborate, learn, and even entertain. We now use networks for browsing information, acquiring knowledge, share events, personal moments in social media, playing games, also entertain like online shopping, book or arrange meetings, and so on and so on. We'll see here in the figure what are the key structure of network characteristics. There are many key structures and performance-related characteristics referred when discussing the networks. The first one is called topology. There are actually two types of topology, physical and logical topology. Physical topologies describes how the network devices are actually interconnected and with wires and cables. They also show how the devices are arranged, which cables are used, which network devices, and also end systems. The logical topology is the path over which the data is transferred in a network, and it describes how the network devices appear connected to a network users. Speed is also a characteristic of the network, and it's a measure of the data rate in bits per second of a given link in the network. While the term speed is commonly used when referring to the network bandwidth, it is not technically accurate. The actual speed that the bits are transmitted does not vary over the same medium. The difference in bandwidth is due to the number of bits transmitted per second, not how fast they travel over wire or wireless medium. So this is the speed characteristics. Another characteristic, of course, is the cost, which indicates the general expense for purchasing a network component and installation and maintenance of the network. Security, which is very important for every network because it indicates how protected the network is. And it also includes the information that is transmitted over the network. Availability is the likelihood that the network is available for use when it is required. So anytime users can access the network. Scalability, this is the performance related characteristics because it indicates how easily the network can accommodate more users and data transmission without degrading the performance of the network. And the reliability also is performance related characteristics. It indicates the dependability of the components that make up the network, such as the routers, switches, PCs, servers, and so on. And the reliability is also measured as probability of a failure or the mean time between failures. All of these characteristics and attributes provide a means to compare different networking solutions. Networks come in many sizes. They can range, for example, from a simple network consisting of 2 computers to network connecting millions of devices. Simple home networks let you share resources such as printers, documents, pictures, even music, and so on, among a few local end devices. So the end devices could be a laptop, tablet, smartphone, printer, even a local server, and so on. Small office and home office, or also called SOHO networks, allow people to work from home or remote office. Many self-employed workers use this type of networks to advertise and sell products, order supplies, and communicate with customers. A larger networks, business networks that uses larger networks to provide consolidation, storage, and access to information on network servers. Networks provide email, instant messaging, collaboration among employees, and others. Many organizations use their network's connection to the internet to provide products and services to customers. And the largest networks in existence is called internet, as you may already know. We all use the internet even now for our online training event. The two most common types of network infrastructures are local area networks and wide area networks, also abbreviated as LANs and WANs. LAN is a network infrastructure that provides access to users and end devices in a small geographical area. And it is typically used in a department within an enterprise, at home, or at a small business network. Maybe it could be used also in the university's campus, while the WAN is a network infrastructure that provides access to other networks over a wide geographical area, which is typically owned and managed by a large corporation or telecommunication service providers. In the future, On the right side of the slide, you can see WANs connected via VANs. A WAN is a network infrastructure that spans a small geographical area and have specific characteristics that are listed here. They interconnect end devices in a limited area, such as home, school, office building, campus, as I mentioned. They are usually administrated by a single organization or individual. Administrative control is enforced at the network level and governs the security and access control policies. WANs also provide high-speed bandwidth to the internal end devices and to the intermediary devices that make the connection to the outside of the WANs. WANs, on the other hand, have specific characteristics. They interconnect LANs over wide geographical areas, such as between cities, states, provinces, countries, or continent even. WANs are usually administrated by multiple service provider, while LANs are administrated by a single organization. WANs are by multiple service provider, and they typically provide lower speed links between LANs or between the networks they connect. The internet is the worldwide collection of interconnected networks, also called internetworks or internet for short. It is actually made of incredibly large number of independently operated networks. What is interesting about the system is that it is fully distributed. There is no central control that is deciding how packets are routed or where a piece of the network are built or even who interconnect with whom. There is end-to-end connectivity in every part of the network because the utility of the net is that any device can communicate with any other devices, just like you want to be able to make phone calls to any other telephone in the world. The net will do the same. So now we have a basic understanding of what makes up a network and what are the different types of networks. But how do you actually connect users and organizations to the internet? As you may have guessed, there are many different ways to do this, and this depends on the type of the network and user requirements. For example, home users, remote workers, and small office typically require a connection to an ISP. ISP is an internet service provider, which provides an access to the internet. Connection options vary greatly between ISPs and depending on the also geographical location. However, here we can see on the slide they are listed the most popular choices, which include, for example, broadband cables, which typically offered by a cable television system, and they provide the internet data signal, which is transmitted on the same cable that delivers cable television. So the media is shared between the cable signal and the internet signal, and it provides high bandwidth, high availability, and an always-on connection to the internet. Another option for accessing the internet is DSL, which is abbreviation from digital subscriber line. It also provides high-speed bandwidth, high availability, and an always-on connection to the internet. It runs over a telephone line. In general, small office and home office users connect using asymmetrical DSL or the so-called ADSL, which means that the download speed is faster than the upload speed. The most popular type of DSL used for home users are ADSL. Another option is cellular internet, where the internet access uses a cell phone network to connect. Wherever you can get a cellular signal, you can get cellular internet access. And here, in this type of connection, the performance is limited by the capabilities of the phone and the cell tower to which it is connected. On the other hand, there are satellite connection. The availability of satellite internet access is a benefit in the areas where there is no another solution, where there is no another internet infrastructure built before. So for this type of network access technology, satellite dishes are required, and a clear line of sight to the satellite also is required. There is also a dial-up telephone. This is an expensive option that uses any phone line and modem. The drawback of this kind of access technology is that it provides a low bandwidth by the dial-up modem connection, and it is not sufficient for a large data transfer. But on the other hand, it is useful for mobile access while traveling. Organizations usually need access to their corporate site as well as the internet. Fast connections are required to support business services, including IP phones, video conferencing, data storage. Also, service provider offer business class interconnection. And here in this slide, you can see a popular internet access technology for the business. They are so-called dedicated list lines. They are reserved circuits within the service providers' networks that connect geographically separated offices for private voice or data networking. These circuits are rented at a monthly or yearly rates, and they provide probably the most secure network type because they are dedicated for a particular organization and they're not shared between organizations. Another type of accessing technology for business is micro Ethernet. This is sometimes also known as Ethernet WAN or Metro Ethernet. It extend LAN access technology into the WAN. Actually, this technology uses the benefits of LAN technologies and introduce these benefits in the WAN technologies. On the other hand, here we can also see that DSL could also be used for accessing the internet, but the most popular choice here for the business is not ADSL, which was asymmetrical, but it is SDSL, which stands from symmetric digital subscriber line, which is similar to the customer version, but provide uploads and downloads at the same high speed. Also, we have satellite options. Satellite service can provide a connection where a wired solution is not available, where there is no networking solution built at all. So now let's see what we now call converged networks. Consider a school built 30 years ago. Back then, some classrooms were cabled for the data network. There were cabled for telephone network and also for video network, for example, for television. These networks are separate, and these separate networks could not communicate with each other because they don't have common point. Each network used different technology to carry the communication signal, and each network had its own set of rules and standards to ensure successful communication. Multiple services run on multiple networks. So this is the traditional separate networks back 30 years ago. But now, today, the separate data, telephone, and video networks converge, or they are combined. Unlike dedicated networks, converged networks are capable to deliver data, voice, and video between many different types of devices over the same network infrastructure. This network infrastructure uses the same set of rules, agreements, and implementation standards. Converged data networks carry multiple services on the same network, on one network. So now the modern networks that use converged networks because we can use it. We can use it simultaneously for data, for voice, for telephone, video, and so on and so on. We do not need to separate networks for all of these type of networks. The role of the network has changed from a data-only network to a system that enables the connection of people, device, and information in memory to converge network environment as we see. For networks to function efficiently and grow in this type of environment, the network must be built upon a standard network architecture. Network also supports a wide range of application and service. They must operate over many different types of cables and devices, which make up the physical infrastructure. The term network architecture in this context refers to the technologies that supports the infrastructure and the program service and rules, the so-called protocols that move data across the network. As network evolve, we have learned that there are 4 basic characteristics that network architecture must address to meet the user expectation. And these characteristics are fault tolerance, scalability, quality of service, and also security. Some of them were listed in the previous slide where the network components were described. But let's see now exactly what they mean. A fault-tolerant network is one that limits the number of affected devices during a failure. It is built to allow quick recovery when such a failure occurs. These networks depend on multiple paths between the source and destination of a message. And if one path fails, the messages are instantly sent over a different link. Having multiple paths to a destination is called redundancy. In order to achieve fault tolerance, redundancy must be implemented. So redundancy allows for alternative path if the active path fails for some reason. Scalability is another factor. It expands quickly to support new users and applications. The scalability is performance-related characteristic. It does this without degrading the performance of service that is being accessed by existing users. So we can add more users to the network without degrading the performance of the other users. We can see this in the figure, which shows how network is easily added to an existing network. And these networks are scalable because the designers follow accepted standards and protocols. This lets also software and hardware vendor to focus on improving products and services without having to design a new set of rules for operating within a network. Quality of service, on the other hand, is an increasing requirement of networks today. A new application available to users of a network, such as voice and live video transmission, create higher expectation for the quality of the delivered services. Congestion occurs when the demand for bandwidth exceeds the amount available. So when the volume of traffic is greater than what can be transmitted across the network, devices will hold the packets in memory until resources become available to transmit them again. So the quality of service is responsible to store packets in buffers when congestion occurs, and also to prioritize traffic, because some traffic must be sent very quickly, the traffic in real time, such as voice and video transmission, while other traffic can wait, but to be sure that it is reliably sent. Securing the network infrastructure includes physically securing the devices and provides network connectivity and preventing also unauthorized access to the management software that resides on them. Network administrator must also protect the information contained within the packets being transmitted over the network and the information stored on the network attached device. In order to achieve the goal of network security, there are 3 primary requirements. These requirements also build the so-called security triangle, and they are called confidentiality, integrity, and availability. Confidentiality means that only the intended and authorized recipients can access and read the data. Unauthorized users are not allowed to touch, to read, to write over the data. Integrity assures users that the information has not been altered in transmission, has not been modified, and it is in the form of origin, so how it was sent by the users to a destination. And the availability is assurance that users have timely and reliable access to the data service for authorized users. As we saw, networks vary in size, shape, and function. They can be complex as device connected across the internet, or as simple as two computers directly connected to each other. However, simply having a wired or wireless connection between end devices is not enough to enable communication. For communication to occur, devices must know how to communicate, just like people communicate with each other. They know how to communicate because they share the common language, for example. In the networks is almost the same, but their rules are called protocols. Sending a message, whether by face-to-face communication or over a network, is governed by rules which are called protocols, as I mentioned. These protocols are specific to the type of communication method being used. Nowadays, day-to-day personal communication, the rules we use to communicate over the medium, like a telephone call, are not necessarily the same as the rules for using another medium, such as sending a letter. So we are using a telephone to make a phone call on one way and send a letter, even in post, on different way. So we can see that in many cases, there are many protocols, and protocols must be able to work with other protocols so that your online experience gives you everything you need for network communication. Protocol suites are designed to work with each other seamlessly. So in order to make possible to make the understanding of protocols, a protocol suite is used. Network protocols define a common format and set of rules for exchanging messages between devices. And they are implemented by the end devices and also by intermediary devices, even in software, hardware, or both. Each network protocol has its own function, format, and rules for communication. We can distinguish several types of protocols. For example, there are network communication protocols that enable two or more devices to communicate over one or more networks. And the example of such protocols are the Ethernet family of technology. Also an IP, TCP, HTTP, and many more protocols that can be listed. On the other hand, there are also network security protocols. Protocols secure data to provide authentication, data integrity, and data encryption. And an example of security protocols are SSH, SSL, security sockets layer, and transport layer security, and many others. In the network, they are also routing protocols. They enable routers to exchange route information, compare path information, and then select the best path to the destination network. An example of such protocols are OSPF, EIGRP, which are examples for interior routing protocols, and BGP, which stands for Border Gateway Protocol, which is an example for exterior routing protocols. And also there are protocols that are used for the automatic detection of devices or service. These are so-called service discovery protocols. An example of such protocols includes Dynamic Host Configuration Protocol, which is DHCP for short. This protocol discovers services for IP address allocation. There is also another widely used protocol for service discovery, which is called DNS, which stands from domain name system, and it is used to perform name to IP address translation. Complex concepts such as how a network operates can be difficult to explain and understand. And for this reason, a layered model is used to modularize the operation of a network into manageable layers. The benefits of using a layered model to describe network protocols and to operate are listed in this slide. And in the figure on the left, actually on the right, show two layers models that used to describe network operation. These models are OSI model and TCP IP model. Since they are described in the next slide, I will change the slide. The OSI reference model provides an extensive list of functional services that occur at each layer. This type of model provides consistency within all types of network protocols and service by describing what must be done at a particular layer, but not prescribing how it should be accomplished. It also describes the interaction of each layer with the layers directly above and below. OSI has 7 layers. On the top, their application layer, which is responsible for data generation and the appropriate formation for transmitting the media. And then their presentation, session, transport network, data link, physical, the most important for the network transport, because it prepares the data from the applications in an appropriate way. The transport layer segments the data. It segments it to small pieces because small pieces are more efficiently transmitted over the networks than big pieces of information. And also their network layer, which is responsible for labeling the data, adding IP information, or just addressing the packets that are going to cross the network. Another reference model that is widely used in the modern communication networks is the TCP/IP. The TCP/IP protocol model for internetwork communication was created in the 70s of the last century, and it's sometimes referred to as an internet model. This type of model closely matches the structure of a particular protocol suite. The TCP/IP model is a protocol model because it describes the function that occur at each layer of protocol with the TCP/IP suite. It is a 4-layered, and here you can see a comparison between the OSI and the TCP. The protocols that make up the TCP/IP protocol suite can also be described in terms of the OSI reference model. In the OSI, the network access layer and the application layer of the TCP/IP model are further divided to describe discrete functions that must occur at these layers. At the network access layer, the TCP/IP protocol suite does not specify which protocol to use when transmitting over a physical medium. It only describes how the handoff from the internet layer to the physical network protocols. OSI layer 1 and 2 discuss the necessary procedure to access the media and the physical means to send data over a network. There are some similarities between the two, as you can see. In here, there is animation in the slide that demonstrates the complete communication process and how TCP/IP protocols are used to send packets between the web browser of a host and a web server. In order to send this type of data, several protocols are used. And these are HTTP, TCP, and IP, which all are part of the TCP/IP protocol suite, and they are used in this particular communication process. And the network layer, network access, sorry, something happened with my presentation, maybe because of the animation. You probably see, but so HTTP is responsible for the rules for exchanging text, graphic, images, sound, video, and other medium files on the web, while TCP is a common protocol, one of the two mostly used in the transport layer, which is responsible for reliable communication between the process running on separate hosts and provides reliable and also acknowledged transmission that confirms successful delivery. And the IP protocol used here address packets for end-to-end delivery onto the network. And Ethernet defines the rules for wiring and signaling standards for the network access. Now I'll talk more about network layer, since there are some protocols which have a main responsibility in the communication process. The network layer, or OSI layer 3, provides service to low-end devices to exchange data across network, as shown here in the figure. IP version 4 and IP version 6 are the principal network layer communication protocols. Other network layer protocols include routing protocols that I mentioned before. These are OSPF, EIGRP, and also there are some protocols such as Internet Control Message Protocol, or ISMP, which is also has some control function in the networks. But now I'll focus on IP protocol, and I will focus on IPv4 and IPv6. In order to accomplish end-to-end communication across the network boundaries, network layer protocols perform four basic operations. These are addressing end devices, encapsulation, routing, and decapsulation. So addressing end devices, in order to send data, end devices must be configured with a unique IP address for identification on the network. They must be somehow identified in the network. Encapsulation is the process performed by each layer, but since we're talking about the network layer encapsulated the protocol data unit, the so-called PDU, from the transport layer into a packet. On the network layer, the protocol data unit is called a packet. And the encapsulation process adds IP header information, such as the IP address of the source and the destination host, and its encapsulation process is performed by the source of the IP packet. Routing is the process that is performed by intermediary devices. To travel to another network, the packet must be processed by a router. The role of the router is to select the best path to direct packets towards the destination host in the process, which is known as routing. That's why the device is called a router, because its main function is to route packets, or routing is a process. A packet may cross many routers before reaching the destination host. And each router a packet crosses to reach the destination host is called a hop. And on the other side, in the receiving side, the process is called de-encapsulation. Actually, encapsulation means that some protocols manage the data and add some additional information, which is a control information. And this information, we call it a header, because it shows important information for the transmission. And the encapsulation means that this control information is removed from the data. To travel across the network, the packets must be addressed in order to distinguish from other packets, and for this purpose, an IP protocol is used. Its role in the network is to encapsulate transport layer segments into IP packets. IP was designed as a protocol with low overhead, which provides only the functions that are necessary to deliver a packet from a source to a destination over interconnected system of networks. And the protocol was not designed to track and manage the flow of packets, because this function, if required, are performed by other protocols. There is no necessity to perform the same task by different protocols several times, so it's not necessary. And primarily, this is done by the TCP protocol, which is a transport layer or layer 4 protocol of the OSI model. The basic characteristic of IP protocols are it is connectionless, which means that IP doesn't require initial exchange of control information to establish an end-to-end connection before packets are forwarded. And packets are forwarded in the way which is called best efforts, which means that the IP protocol doesn't guarantee that all packets are delivered and are received. If out-of-order packets are delivered, so packets are missing, then the application using this data or upper layer services must resolve this issue. This is not an IP responsibility, so that's why it's called best effort. It sends data no matter if this data is delivered actually. This allows IP to function very efficiently, and also IP is very independent because it operates independently of the media that carry the data at lower layers of the protocol stack. So we see that IPv4 is actually one of the primary network layer communication protocols. And here you can see an IPv4 packet header, which is used to ensure that this packet is delivered to its next stop on the way to its destination and device. An IPv4 packet header consists of fields containing important information about the packet. These fields contain binary numbers, which are examined by the layer 3 processes. And the most common reference fields are the source and destination IPs, since they identify where the packet comes from and where it is going. Typically, these addresses do not change while traveling from the source to the destination. But in the modern network, they change somehow because the IP separates private and public addresses, and there is a mechanism called network address translation that changes end-to-end connectivities. There are other fields like internet header length, total length, header text sum that are used to identify and validate the packet. And also other fields for reordering of fragment packets. These are identification, flag, fragment, offset fields to keep track of the fragment. A router may have a fragment IPv4 packet when forwarding from one media to another with a smaller MTU. So if the packet is too big to be transmitted on the media, the router must fragment or separate the packet into smaller pieces. And in order to know which pieces is for what, it should identify the pieces by these fields. IPv4 is still in use, but its 32-bit addressing length provides approximately 4.3 billion IPv4 addresses, which are not enough for the constantly increasing number of IP-enabled devices. In order to deal with this limitation, IPv4 protocol of this protocol, a newer version called IPv6 was developed. Before IPv6 to get into the modern networks, there are some mechanisms that address the limitation of IPv4. So in order to save addresses, a mechanism called network address translation was developed, but this mechanism brings another problem to the network. It breaks the end-to-end connectivity between devices, as I mentioned on the previous slide. It is also increases the network complexity, it creates latency, and also make troubleshooting of networks more difficult. To overcome the limitation of IPv4, IPv6 comes, and it is a powerful enhancement with the features that better suit current and foreseeable network demands. IPv4 provides 32-bit addressing scheme, as I mentioned in the previous slide, which provides approximately 4.3 billion addresses. Unfortunately, not all of them are valid and used for addressing the host. IPv6 overcomes this limitation by extending the addresses to 128 bits. And in order to calculate the number of addresses, the IPv6 protocols can provide, we need to compare to compute 2 to the power of 128, which is a number called undecillion. Well, it's quite enough addressing space for the new users, And the decillion is a number which is 10 to the power of 36, which is, yeah, a big value. IPv6 also improves the packet handling by simplifying the header and eliminates the need for NAT, for network address translation. Here we can see the improvement of the IPv6 header. One of the main improvements is that the IPv6 uses a simplified IPv6 packet, as I mentioned. For IPv6, some fields have remained the same. Some fields have changed in names and position, and some fields are no longer required. For example, the fragmentation of packets, which is a process done by in IPv4 networks when, for example, changing the media from one media to another media where the maximum transmission unit of the newer media is smaller, the router fragments the data into smaller pieces, and this operation is no more done by the IPv6 network routers. That's why there are no identification, flag, and fragment offsets fields in the header of IPv6. Also, the length of the header is a bit longer. Of course, it's 40 bytes because the length of IP address is larger, but it is fixed. So there is no need to add a field that shows the length of the header. There are also an option to add additional headers if some additional information is required, but these headers are added as extension headers, as new headers, while in the IPv4 they're added as an option in the IPv4 header, and that's make the header a variable. So to here was the first part of my presentation. And since Hamed said that we can make a short break, if you want, I can give you, for example, 10 minutes break. The second part will be a little bit shorter. So I hope that we can finish it until 6:30, I think. Yeah.
Okay, thank you, Diana. So thank you for this first step. So now we can go to a break for 10 minutes, and after we'll have Diana again, and we'll do a break again, and Plamel will start his talk in the next session. Thank you.
Thank you too.
So
See
we
you in
stay
10 minutes.
we stay connected, huh? Everybody stay
Yeah,
connected. Okay,
I'll
great.
be here also. Yeah. Okay.
Thank you, Diana. Roxanne, you are here? Okay, Roxanne, you can hear me?
Okay, yes, I hear you. Okay,
Okay,
but
so I'm
yes.
sorry, I have to, I had to first to allow you to use your microphone. So that's why
Thank
you
you.
were not able to speak. Okay, I hope that this first session was okay for you.
Oh, it's
And,
very okay, and
okay.
and the presentation is very great.
Okay, okay, great. So remember that if you have some question, to use the forum, and because only question asked through the forum will have a feedback. Okay.
Mm-hmm. Okay.
And that's it. And so what I can show is for the students that are listening to us, I can show them what is going to happen in the next step. Okay. First of all, so the students will have this seminar today, and today and the next one will be done by people, teacher from Russia, almost, I think. Yes, almost only people from Russia. And it will be the 28th of April that the teacher from Grenoble. Grenoble is a city in France, close to my city, Lyon. So from the University of Grenoble, there will be the turn of their turn to make the courses. So it will be Professor Stéphane Mocanou, Professor Jean-Marc Thirier, and Denis Génon Catalan. Okay. At the end of all this seminar, we will ask to the student to fill a survey again to see how they react, how they have interest in what they have seen. Okay, the survey is not yet available because we have to wait first that all the seminars are done, and when they will be done, we will be able to submit this questionnaire to all the students again. Okay. And I forgot to say that in this page, today you have only the CV of the speaker, the seminar program, but I will put the PDF of the slide of the teacher, okay? They are going to send it to me after, and I will make it available to all the students and the teacher, if they allow me, of course, but normally they will allow me to put it in Moodle, like that. Every student and each teacher will be able to have a copy of the slide. Okay.
Okay, that's great.
Okay. Okay.
I'm here again. Should I
Okay.
continue? Or?
Great, great. So you can start when you want. Just to let you know something, it's a technical advice. If if it appear a problem, okay, when you put you make your presentation, for example, if you have some perturbation on or some noise, bad noise, so you just have to go out of the Zoom and come back. Usually when you have this kind of noise problem, you can solve it just by going out and coming back. Okay,
Okay.
It's an advice for the next seminar that are going to be organized.
Yeah.
Okay, you can take the lead. You can take the lead.
Okay.
Thank you.
So, about the presentation, I will send a PDF version to you after
to me. Great.
training, and I will allow you, of course, to
Okay,
upload
great.
it in the
Thank you very
So,
much. Thank you very
I don't,
much.
I don't mind it.
And
Oh.
you know that next year the teacher from Mefalo will do their own slide. They will use your expertise. They will learn from you, so that which is
Yeah.
very good. That's very good.
Yeah, of
And
course.
they will design their own slide. They are not going to
Yeah.
use the same slide, of course, because they have to
Mhm.
learn more. But of course, we
Like,
hope.
use it like a reference.
Yeah, and we hope that when we'll be able to travel, so it means that they are going to come to your place or to my place to train one time, and after we'll go to their place to train them again on PLC. So it means that we can imagine that with the seminar that you are doing, with the training that they are going to get, they will be able to make a courses by themselves, and we will help them to do so. That's the spirit of this project. Okay,
Yeah.
I give you the leads now. It's your turn.
Thank you. And I'll share again the screen.
Okay.
Yes, and I will start the presentation. So the next part is called routing and switching principle, network devices, types and characteristics. I will continue with this topic, which follows the agenda. The slides are numbered. I mean, this part is on the same file, so on the same presentation, but the slides, as Ahmed said, are numbered. So if you have any question about any of the topic, please just refer to the corresponding slide number. And I will continue with the basic routing and switching principle. All computers that are connected to
Jenna, I think sorry, I think your screen is not shared. No?
I'll just share it. I have a button which says.
You have it? Okay. Okay, so sorry.
Can you see it?
So it's me that I have a problem. Okay, thank you.
But it is seen by the others. Is it seen or? I think it's shared. So all computers that are connected to a network and participate directly in network communication are classified as hosts. Hosts can be called end devices, and some hosts also called clients. However, the term host specifically refers to a device on the network that is assigned with an IP address. We already mentioned what an IP is and why it is used in the network. It is used, just to remember, for the identification of hosts in the network to which the host is attached. On the other hand, there are servers, which are also computers, but they are installed with software that allow them to provide information like email or web pages to other end devices on the networks, which act as clients. Each service requires separate server software. For example, a server requires web server software in order to provide web service to the network. A computer with a server software can provide service simultaneously to many different clients. And clients are type of hosts. They have software for requesting and displaying information obtained from the server. This is a model which is called client-server model, and it's widely used in many applications in the networks. An example of client-server model is web traffic, because we have a client with software which is called web browser, like Chrome or Firefox or any other, and a single computer can also run multiple type of client softwares. For example, a user can check emails and view web pages while at the same time messaging and listening on the audio stream. And here in the table, they are listed the three common type of server software on the other hand. Clients and server software usually run on separate computers, but it is also possible for one computer to be used for both roles in the same time. In small businesses and homes, many computers function as the servers and clients on the network. This type of network is called peer-to-peer network. And there are some advantages and also disadvantages for this networking model, which are shown here. The advantages include that they're easy to set up, they're less complex, they have a lower cost because network devices and dedicated servers may not be required. And peer-to-peer model can be used for simple tasks such as file transferring and sharing printers. On the other hand, there are some disadvantages. There is no centralized administration. For example, if there are the need for some kind of authorization, the username and password must be stored on both devices, which is decentralization. And this provides some security issues because the password is stored on a different machines. It is required to be shared more devices, not like the centralized one. Peer-to-peer network are not scalable because adding more devices to the network will degrade their performance. No devices may act as both clients and servers, which can also slow their performance. So scalability and performance are performance-related characteristics. The network devices that people are most familiar with are end devices. To distinguish one end devices from another, each end device on a network has an address, which is called IP address, as described in the previous section. When an end device initiates communication, it uses the address of the destination end device to specify where they delivered the message. And end device is either the source or destination of the message transmitted over the network. Intermediary devices, on the other hand, are devices that are responsible for transmitting data from individual end devices to the network. They can connect multiple individual networks from internetwork. And these intermediary devices provide connectivity and ensure that data flows across the network. Intermediary devices use the destination end device address, which is stored in the IP header in the field of destination address, in conjunction with information about the network interconnection to determine the path that the message should take through the network. Example of the more common intermediary devices shown here in the figure. The most common network devices used in almost every network are switches and routers. Switches are layer 2 devices which make possible multiple end devices to be connected on the same local network, while the router is layer 3 devices and with main responsibilities are to forward packets between networks. So the router makes its responsibilities is to connect different networks. Communication transmits across a network on media, and the media provides the channel over which the message travels from source to destination. Modern networks primarily use 3 types of media to interconnect devices. These type of media are meta-wires within cables, in which the data is encoded into electrical impulses. Glass or plastic fiber within cables, also called fiber optic cables, where the data is encoded into a pulse of light. There is a laser that emits light, and the data is transmitted like pulse of light. And there is also wireless transmission, where the data is encoded via some kind of modulation of specific frequency of electromagnetic waves. So these are 3 common types of network media. Of course, there are different standards, but the types of media are only these 3 types. With both IPv4 and 6, packets are always created at the source host. The source host must be able to direct packets to the destination host, and to do this, host and device created its own routing table. This routing table showed the host where and how to transmit the data that the host prepared. And the host can send packets to the following. It can send a packet to itself. This is typically done by using a so-called loopback address. For IPv4 is the whole addressing space, while for IPv6 is the only one address. And the main purpose of pinging itself, let's say it like that, is to test the TCP/IP protocol stack on the host. On the other hand, local host, it can send a packet to a local host. This is a destination host that is on the same local network as the sending host. And the source and destination hosts share the same network address. So if we see here in the figure, PC1 and PC2 are in the same network. They stand on the same side of the router, so they share the common network. So they're local hosts and they're parts of one local network. And also, a host can send a packet to a remote host. This is a destination host on a remote network. The source and destination host do not share the same network address. Like, for example, this server, which is on the another side of the router, which is on another network. Whether a packet is distinguished for a local host or remote host is determined by the source end devices. The source end devices determines whether the destination IP address is on the same network that the source device itself is on or not. And if it's not on the same network, then the current device must connect to the router, because the router is responsible for routing traffic between networks. And in these cases, the router is also default gateway. A default gateway is the network device, which also could be a layer 3 switches, but most commonly is a router, of course, that can route traffic to the other networks. If you use an analogy data network, it's like a room, when the default gateway is like a doorway. So if you want to get to another room or network, you need to find the doorway. The same way is in the network. On the network, a default gateway, usually a router, has these features. It has a local IP address, which is from the same addressing range as other hosts on the local network segment. It can accept data into local network and forward data out of the local network. It routes traffic to other networks, and default gateway is required to send traffic outside of the local network. If there is no default gateway, then the host will not be able to communicate with remote networks. So traffic cannot be forwarded outside the local network if there is no default gateway, or in some reason it is not configured or it's down. A host routing table will typically include a default gateway, and in an IPv4, the host receives an IPv4 address of the default gateway, either dynamically by DHCP or it is configured manually. In IPv6, the router advertises a default gateway address, or the host can be configured again manually. So here it is given an example in which PC1 and PC2 are configured with IP addresses, and they use the address 122.168.10.1 as the default gateway, and this address is configured on the local interface of the router that is connected to the network of PC1 and PC2. Having a default gateway configured creates a default route in the routing table of the PC. And this route is the pathway your computer will take when it tries to connect on remote networks. So when both computers, PC1 and PC2, want to communicate with the host outside of its local network, for example, remote networks or internet networks, they must go first to the default gateway. And here you can see a screenshot of Windows host routing table that is printed via route print on /r command, which is used to display the host routing table. Both commands generate the same output. And at first, this output may seem a little bit overwhelming, but it's very simple to understand. It consists it's like a table which consists several columns. The most important are interface list, IPv4 root table, IPv6 root table. The first one, interface list, lists the media access control that addresses and assign interface number of every network capable interface on the host, including internet, Wi-Fi, Bluetooth, even because Bluetooth is also kind of network interface that make some kind of network connectivity between different devices. IPv4 routing table lists all known IPv4 routes, including direct connections, local networks, and local default routes. And the same is for IPv6 routing tables, but they about the IPv6 networks. So now we'll talk about routing, but before we start with routing as the process, let's first see what a router is. A router is just a specialized computer that performs basic routing operation processes in the network, and it has several hardware components inside of the box that make possible the operation of the router, that makes this device to act like a router. The device has a power supply, which is of course common for all electrical devices. What makes the router different from the contemporary computers is that it is internetworking devices, and as such a device, it has multiple interface cards. So in network interface cards, they are separated in two groups, LANs and WANs. The router may have several LANs, several WANs, and for example, for local area connection, they are fast Ethernet cards, and for WAN connection, there are several serial cards, which are used for building WAN networks, for example. Other computers of the router include different memories. These memories could be NVRAM memory, ROM memory, flash memory. All of these memories that I have just set are non-volatile. Even NVRAM, which ends with RAM, we know that RAM is volatile, but with non-volatile, which means that it's non-volatile, which means that it stores permanently information. The router has also a CPU module for processing the main task and advanced integration module options that offers processor-intensive functions such as encryption from the main CPU. When the device is running, we know that the operating system, some kind, operates, and to make possible to this to happen, the operating system is loaded into dynamic RAM memory. This is also a random access memory, which is a contemporary memory, also seen in the standard PC computers and laptops, and also RAM memory also stores other information such as the routing configuration file, routing table, and also it provides packet buffers when there are congestion in the networks and the router cannot process the data as it comes to its interface. It must store that information in order to not to reject the connection. This is done by using buffers that stores packets when they're congestion. So routers have different types of memories. I have already mentioned one of them. RAM memory is a volatile memory that provides temporary storage for various applications. It it is not permanent because when the device is reloaded or when it lost its power supplies, all the information that is stored in the random access memory is deleted or the memory is cleared. So while there is a power supply to a device and the device is running, the RAM stores some information. And the most important information is the running operating system. It's the running configuration file or the configuration that the administrator made with the devices running in the RAM memory. Also IP routing table, RP tables, packet buffers, and so on. There are also read-only memory or load ROM memory, which is a type of non-volatile memory that provides permanent storage for boot up instructions. When the device is booting up, there is a program which is called loader, which is kind of machine instructions for localization and loading the operating system in the RAM, because typically the operating system is stored in the flash memory, but when the device is running, the operating system is stored in the RAM. There is also a basic diagnostic file in the ROM memory, and also a limited IOS or limited kind of operating system, which is used in case when the router cannot load the full featured IOS. About the NVRAM memory, the most important function is to store the startup configuration file. So when we make some configuration changes to the router, we store it in the running configuration file, which is stored in the RAM. But when we reload the device, all of this information is cleared. And if we want to keep the configuration, we must copy the running configuration into the startup configuration in order to save it permanently on the device. And also there is a flash memory, which is non-volatile memory that provides permanent storage for the operating system and also other related files. Here we can see a back panel of a router, which has several interfaces. It has traffic interfaces, let's say traffic interfaces. They are divided into LAN interfaces and WAN interfaces. Here actually we don't see WAN interfaces because the slots are empty, and we also see the cover. So this is slots for WAN interfaces, but there is no WAN interface installed in this router. But we can see WAN interfaces. These types with RJ45 connectors are example of LAN interfaces of type fast Ethernet, or they could also be gigabit Ethernet. And there are also two types of interfaces which are called manageable interfaces. One of them is called auxiliary port, and the other one is console. Console interfaces is only used for configuration of the device. So here, when connect a computer, we can use this connection only to configure the device. Other LANs and WANs are used to transmit traffic generated by the device. Here in the animation, we see what happens when a packet arrives on a router interface. The router examines the destination IP address of the packet and searches its routing table to determine where to forward the packet. And the routing table contains a list of all known network addresses and where to forward the packet. These entries are known as routes, and the router will forward the packet using the best matching route found in the routing table. If there is no route installed for the current traffic for the current packet, the device will reject or delete the packet and will not send it to its destination. And here we can also see an example of how routers forward packets in a given scenario. First, where there is one, we can see that packet arrives on the gigabit Ethernet 000 on the router R1. What does the R1 do is R1 then encapsulates the layer 2 Ethernet header and trayware and examines the second phase, examine the destination IPv4 address of the packet and start searching its routing table for the best match. The route entry indicates that the packet is to be forwarded to R2, as we can see from the matching entry in the routing table. And the router will encapsulate the packet into a new Ethernet header and trayware and forward the packet to the next hop router. The routing table of the router contains network route entries listing all possible known network destinations. The routing table stores 3 types of route entries. These are directly connected networks. When a router has an active interface which has been configured with an IP address, the network of this address is added as an entry in the routing table, and it is added as a directly connected network. All networks that are not directly connected to an interface of the routers are referred as remote networks, and they are added in the routing table either statically by the administrator or dynamically by the network routing protocol, which was previously configured. And like the host, there is another route entry, which is called default route. It is also known as gateway of last resort, and this route routers uses only when there is no better match in the IP routing table. So the default route matches all packets, but if there is a longer match, the longer match is considered. Here's an example of how packets make decisions, and we can see in the figure how directly connected and remote networks are related to router R1. For R1, they are 2 directly connected networks, and they are marked with yellow circles and ellipses. So these are directly connected because the router has an interface that participates in this network. That's why they are directly connected networks. But we can see that there is also a remote network, which is the blue one, the blue circle. And these directly connected networks is not known for R1. It must be learned for R1 in two different ways. Manually, the administrator manually add them into the routing table as static routes, or dynamically by using a routing protocol like OSPF, EGRP, and others. And now we'll see what are statically routing and what are dynamically routing, and we will finish with this section of the presentation. So the figure above shows an example of a static route that was manually configured on router R1. The static route includes the remote network address and the IP address of the next hop router. If there is a change in the network topology, the static route is not automatically updated and must be manually reconfigured. For example, in the figure below, we can see that the static route that R1 has to reach the network that PC2 is connected to is via R2. But if the path is no longer available, as we see, R1 would need to be reconfigured with a new static route to the same network, but via R3. So here in the next example, the below example, we can see that we have alternative path, we have redundancy path. So if this path is no more available, we have alternative path. So the R1 can reach the network of PC2 by using R3 as the next hop route. But this route must be reconfigured when using static routing by the administrator. And static routing has the following characteristics. It must be reconfigured manually, as we saw. The administrator needs to reconfigure a static root if there is change in the topology and the static root is no longer available. A static root is appropriate for a small network and when there are few or no redundant links. And it is used commonly with dynamic routing protocol for configuring the default route, because default route is also kind of static routing. And dynamic routing protocols, on the other hand, allows the routers to automatically learn about remote networks, including a default route from other routers. So here, what the administrator must have done is to activate and configure the corresponding dynamic protocol. Routers that use the dynamic routing protocols automatically share routing information with other routers and compensate for any topology changes without involving the network administrator. If there is a change in the network topology routes, the routers share their information using the protocol that is configured and automatically update their routing table. Basic configuration only requires the network administrator to enable the directly connected networks within the dynamic routing protocols. And the dynamic routing protocols will automatically do the following. They will discover remote networks. They will maintain up-to-date routing information. They will choose the best path to the destination network. So if there are two paths to one network, they either choose the best one, or if both have the same metric or both are the same best, so it can load the traffic, it can perform load balancing between the two alternative paths. When a router is manually configured with a static route or learns about remote networks dynamically using a dynamic routing protocols, the remote network address and next hop address are entered into the IP routing table. So as shown in the figure below, if there is a change in the network topology, the routers will automatically adjust and attempt to find the new best path without the administrator, without the need to reconfigure something, because the routing protocols will do this for them. This was for the routing. Thank you for the attention. The next parts should be taken from Kwamen. I hope that he's already in the room.
Is with you, Tiana? I have to make him a co-animator, or he's in the same room of.
Is it here, or you can see it?
Let me check. I think Mr. Plamel.
I can try to call him.
Yeah, because I think he's not yet with us. I'm checking, but not yet, I think.
Okay, I will try to call
Yeah,
him.
you can call him, and of course we can make a break now again. Okay, let's say.
Yeah, of course.
Yeah, we can do let's say no more than 10 minutes break, and again I want to thank everybody to be here to attend this first seminar. Okay. I want to advise the student. You are listening now, the student. I'm speaking to you now. I want to tell you that don't be afraid if you don't understand everything that you see on the slide. Okay, it could be normal, because you are taking these courses for the first time. So it will take time to make you an expert on this subject. Okay, I'm completely confident that the teacher in Mefalo are very good to bring you to this level at the end of your degrees. So I know some of your teachers there, so I know them very well, and I know that they're very, very active and dynamic for that. And today we try to improve the understanding of these topics by having the point of view of some EU teacher, and that's why sometimes it could be a bit difficult to follow and to understand everything. But as I said, don't worry. To gain expertise, it's question of time and work, of course. Okay, yeah, you have to be involved in this subject. Sure, we will be able to give you some book as a reference about it, and you will have the slide. And don't forget that you have the opportunity to ask your question using the forum. It means that if you want to ask a specific question, it's possible. Just use the forum for that. That's it for my explanation. So now we are going to have a break, a little break, and we wait the next speaker, Professor Plamen, who will come soon.
I want just to say that Plamen will arrive very soon, maybe just in 5, 6, 7 minutes.
So, Diana, thank you very much.
Thank you too. Yeah.
You know, I didn't understand everything, but I recognize something that I have seen during my education. But I'm not specialist of automation, and to let you know, I'm more in electrical engineering. So you know, it's always something very difficult
This is
for me.
additional information that could be
Yeah, and it's crazy because now digital is going inside the energy, so I have to follow, I have to understand this subject to be able to be on the mood. Okay, thanks again,
more subject,
Diana.
more subject, more opportunities. Thank
Yeah,
you too.
yeah. I remember my visit to your place, and it was very interesting at this time too. I was impressed. Okay, great.
You're welcome again.
Yeah. So don't forget to send me your presentation. I will let it available for everybody in Moodle, and
I will send the presentation in a few minutes.
Okay, and tomorrow we will have you will be one of the speakers tomorrow, I think, with Chulalongkorn University. Huh? That's it, huh? I think tomorrow. Tomorrow.
Tomorrow at 10-hour time, but
Yeah.
maybe.
Yeah, that's it.
Yeah.
In the morning, yeah, for you. Okay. Thanks again.
Yes.
I wait Plamen. When Plamen is ready, I will make him a co-animator.